Alright guys, right now we're going to talk about the coagulation cascade. Now there's a lot of different things going on here. Of course you have a lot of different numbers and a lot of different names, so my goal right now is to try to simplify this process for you. Okay, so let me just throw this disclaimer out there by saying that of course there's a lot of different things to talk about when talking about the coagulation cascade. And just like many other things, things could always get more specific, or things could always be more broad. I do my best here to describe the coagulation cascade in depth enough to cover everything that I think is needed for the boards. But keep in mind, there might be stuff on here that you don't need to know, and by the same token, there might be some stuff not on here that you do need to know. So just keep that in mind, my little disclaimer. Alright, first off, let's just really quick talk about the overall general names of the different things found in the coagulation cascade. So real quick, first off in blood, there's two different things. You have serum and you have plasma. Now of note, plasma is actually the portion of the blood that contains fibrin and fibrinogen. Okay, so first off, fibrinogen is found in the plasma and is converted to fibrin by an enzyme called thrombin. Now thrombin is actually the activated form of the enzyme. Prothrombin is the inactivated form. Prothrombin is of course formed in the liver and is activated to thrombin by two things: thromboplastin and calcium ions. So thromboplastin and calcium ions activate prothrombin to thrombin, and thrombin activates fibrinogen to fibrin. Of note, thrombin specifically acts on the arginine-glycine linkages of fibrinogen to make it fibrin. Okay, now when it comes down to breaking apart a clot, plasminogen is of course activated to plasmin, and plasmin cleaves the peptide bonds of the fibrin, and the clot is dissolved. Of note here, plasminogen, while it's converted to plasmin, this is done by plasminogen activators, or most specifically, while there may be other ones, the one that we really need to know is urokinase, which is again produced in the liver. Okay, so that out of the way, just getting the brief names down, the terminology, right? Let's talk about coagulation. So coagulation, overall, there are two types. You have primary coagulation and secondary coagulation. Primary coagulation is where platelets immediately form a plug, and secondary coagulation is clotting factors form fibrin strands. So primary coagulation basically deals with platelets. Secondary coagulation basically deals with fibrin being formed. Alright, so here's my little illustration of a blood vessel with a little leak in it. So this is where the leak is, and this little brown area right here is my illustration of the platelets and fibrin forming a clot. Now of note, in any given area of the blood vessel, in the endothelium of the blood vessel, so right in the middle of the blood vessel lining, you have von Willebrand's factor. And right on the outside surface of the blood vessels, not where the blood is, but on the outside, you have tissue factor, which is found on the outside of the blood vessels. So, of course, unless the blood vessel is ruptured in a healthy blood vessel, tissue factors and von Willebrand's factors should not be in contact with the bloodstream. Okay, so now let's say that hypothetically, the vessel burst, and now these factors are exposed to the bloodstream. So overall, first off, let me just throw this out here. The platelet and fibrin-containing clots. Platelets are the cellular component, while the proteins are the coagulation factor. Again, keep in mind that there's primary and secondary coagulation. Alright, so real quick first, we'll get back to the tissue factor later, but let's talk about von Willebrand's factor. Now, von Willebrand's factor, once it's introduced from the endothelium into the bloodstream, recruits a few different things. First off, it recruits factor VIII, it recruits collagen, and it recruits a few other clotting factors that, for the sake of this demonstration, we're not going to talk about. Alright, so first off, let's talk about collagen. Platelets bind directly to collagen, and this is strengthened by the von Willebrand's factor directly. So von Willebrand's factor not only recruits collagen, but increases platelets binding to collagen. Alright, so platelets, when they bind to collagen, they release a few granules from the inside of their cytoplasms, which contain a few things. They contain ADP, serotonin, platelet activating factor, or PAF, von Willebrand's factor itself again, platelet factor 4, or thromboxane A2, or TXA2 for abbreviation. Alright, so while platelets bind to collagen, something else happens. There is an increase in the calcium in the cytosol of the platelets themselves. So when there's an increase in calcium in the cytosol of the platelets, this activates protein kinase C, which activates phospholipase A2, which modifies the integrin membrane glycoprotein 2B/3A. I know that's kind of specific, which increases the affinity to bind fibrin. And then overall, on top of that, with the modification of the glycoprotein 2B3A, the platelets change shape from a spherical to a stellate shape, and stellate's more like a star shape. So two things are going on here. Through this entire process here, from the increase of calcium with the activation of protein kinase C, phospholipase A2, and then glycoprotein 2B3A, you have two things going on. An increase in affinity to bind fibrin, and the platelets change shape from spherical to stellate. And all this is done when platelets bind to collagen because of von Willebrand's factor, which is found in the endothelium of the blood lining cells. Okay, so overall, we just talked about primary hemostasis. Now, which contains, of course, the platelets. Now let's talk about secondary hemostasis. This is my little transition area. Now, of course, secondary hemostasis or coagulation is clotting factors from fibrin strands. So now we're going to move from platelets to fibrin itself. So this is when we start talking about, with secondary hemostasis, this is where we start talking about the coagulation cascade. And just keep in mind that coagulation factors are usually, the ones we're going to talk about, are usually serine proteases. Okay? So with the coagulation cascade of secondary coagulation or hemostasis, there's two different pathways. You have the intrinsic and the extrinsic. The intrinsic is contact activation, while the extrinsic is tissue factor. Let's talk about the extrinsic first. Alright, so the extrinsic starts with the tissue factor, which we talked about all the way up here. The tissue factor is found on the outside of the blood vessel linings. So once the tissue factor is released into the bloodstream from damage to the blood vessel, moving back down here, tissue factors right here. Factor 7, which is usually found in circulation, contacts the tissue factor. So this is how the extrinsic pathway first begins. Factor 7 contacts the newly released tissue factor in the bloodstream, forming tissue factor 7, or abbreviated TF, Roman numerals 7. Now, bear in mind here that tissue factor 7 activates two different molecules, factor 9 and factor 10. Now, when it comes to factor 10, realize that when tissue factor 7 activates tissue factor 10, this is almost immediately inhibited by tissue factor pathway inhibitor, TFPI. Factor 10 is one of the key players in the coagulation cascade, so to realize that there's a lot of inhibitors and there's a lot of activators. Going back to tissue factor 7, this is the extrinsic pathway. Tissue factor 7 activates 9 and 10. Okay? Now let's talk about 10. 10 forms with 5 and forms the prothrombinase complex. Sorry, I had to look at my own handwriting. So 10 forms with 5 to form the prothrombinase complex, which activates prothrombin into thrombin. So going back up here to our original chart with prothrombin, which is formed in the liver, to thrombin. And originally I said it was thromboplastin and calcium ions. Getting a little more specific now, we now know that thromboplastin and calcium ions are part of the thrombokinase complex. Okay, so prothrombin is activated to thrombin, and thrombin activates such things as factor 5, factor 8, and factor 8 with von Willebrand's factor. Okay? Factors 5 and factors 8 activate factor 11. The factor 8 attached to the von Willebrand's factor which we talked about before, activates at factor 8. Okay, so now we're dealing with two different things here. Let's go back up here. Factor 5 and factor 8 activate factor 11, which activates factor 9, and you have factor 8. So factor 8 and factor 9, I'll zoom out for a second here. As you can see, these guys form the 10A's complex. So this may very well be a question. Factors 8 and factors 9 form the 10A's complex. Okay? And then keep in mind that the 10A's complex, which we'll talk about more in a second, this is a key player in the coagulation cascade, and it requires calcium to function. So calcium is a regulator of the coagulation cascade. Now, the 10A's complex does two different things. It activates factor 10, which, going back all the way down here, this the cycle continues, because remember, factor 10 was down here. Tissue factor with 8 makes factor 10. So looking back up here, this is a positive feedback loop. So factor 10 from the 10A's complex goes all the way back down here, and the cycle continues. Now, the 10A's complex, okay. So right now we're left with the 10A's complex, and this is the extrinsic pathway. Let's talk about the intrinsic pathway for a second. So going back over here to the coagulation cascade of secondary coagulation, the intrinsic pathway, or the contact activation pathway, begins with a few things going on here. So you have collagen, which is activated by kininogen and factor 12, and you have kallikreins. Pre-kallikreins are actually converted to kallikreins through collagen. Okay, but overall over here you have factor 12, which is activated, and this is called Hagen's factor. Hagman's factor, I'm sorry. Factor 12 is Hagman's factor, and factor 12 in the intrinsic pathway activates factor 11, which activates factor 10, and again, which as we talked about, I'm sorry, factor 9. As we talked about, factor 9 and factor 8 form 10A's complex. So both the intrinsic and the extrinsic pathways deal overall. I know there's a lot of different numbers and a lot of things going on. Factor 9 and factor 8 forming the 10A's complex. Okay? But overall here, even though the 10A's complex is important because it enhances the activation of factor 10, which does many other things here, thrombin is a key player here. And we talked about thrombin over here. But going back, let's see what thrombin does. Thrombin, okay, because both these cycles are positive feedback loops, will now go up here, okay, and this is called, it doesn't matter if it's the intrinsic or extrinsic pathway, this is now called the final common pathway. So you have thrombin, okay, which of course activates fibrinogen to fibrin, okay, and thrombin activates factor 8, factor 13, and factor 5. Now factor 13, keep in mind, you have fibrin polymers, and factor 13 turns fibrin polymers into fibrin monomers. So now we're talking about the breakdown of a fibrin clot. Okay, now going back to fibrin for a second, it also produces protein C in the presence of a thrombomodulin. Okay, so thrombin produces protein in the presence of a thrombomodulin. Okay, so as you can see, this is how the entire, going back to the original chart we were looking at, this is how the entire process first takes place, with thromboplastin calcium ions, or the 10A's complex, activating thrombin, and fibrinogen, which is already found in the plasma, not the serum, is activated at fibrin. And this is how the entire cascade takes place. Okay, so over here, this looks very simple, but as you can see, when you talk about it a little more in depth, things can be a little more complicated. Alright, well that concludes this explanation. Bear in mind, there might be some stuff on here that you don't need to know, and by the same token, if there's anything on here that you didn't feel comfortable with, definitely look it up.